All right, guys, we're getting into 1.4, which is functions. Functions are huge. So we're going to look at domains. We're going to look at real life situations. We're going to look at how to evaluate functions. So let's take a look first at the definition of a function. A function is f. From a set A to set B is a relation that assigns each element x in the set A exactly one element in y. So A is your domain and B is your range. We're going to talk more about that, so just hang on. The characteristics of a function from set A to set B. Each element A must be matched with an element in B. Some elements in B may not be matched with A. That's okay. 2 or more elements, domain. All right. Let's go to 4 ways to represent a function. So we've got verbally by a sentence, numerically we're doing a table, graphically is where we're actually plotting points, and algebraically is by equations. Now, when we're looking at functions, my favorite way to do this is pretty much with a line, because there is a test that you can do graphically that makes this really super easy compared to what they're doing. So if you graph it, it makes more sense. So I'm just going to try to give you the easiest way. But if we take a look here, it says we need to look at the input value, x, is the number of representatives from a state, and the output value, y, is the number of senators. So honestly, all this is really telling you is if you do, it's called a vertical line test. And the vertical line test is the one that tells you whether it is a function. I mean, they make it sound so difficult in here, but honestly, that's what you're doing. So take a look here. If I do a vertical line all the way down through each point, do I hit another point? No. So what that means is C is a function. It is, literally, it describes y as a function of x, which means y is your output depending on your x value. So when you put an x value in, right, you should get that one, or when you should only have one x value when you do your graph. That's what it's telling you. So if we take a look at B, you'll notice that the input value of 2, so x is 2, y is 11, x is 2, y is 10. So look at this. When x is 2, we've got y as 11, and then we got y as 10. If I do the vertical line test, it hits it twice, which tells you that's not a function. That's pretty much the gist of this. All right, let's move on to the next page. And so here, we're going to skip the testing function there, and we're going to take a look at this next one. So example 2, testing for functions represented algebraically. So for example 2, what we do is we take a look at that and we want to see what happens. So y equals, or x squared plus 1, y is equal to 1. So one of the ways we could do this is solve for y. So y is equal to negative x squared plus 1. That means I can put x's in there. I'm always going to get that one y value. So if I put in x is 1, then y is 0. If I put in x is 2, then y is negative 3. So it doesn't matter what x it comes in, I'm going to have a distinct y. It means I'm not going to have a repeated y. So this is a function. Let's take a look at the next one. So y squared equals negative x plus 1. And then you have to do the square root property. Okay, so now we get this, and this indicates that that there are 2 y's per x. So again, the easiest thing to do is just to graph it. All right, let's go down to this next one. Oops. So here, this is what I was talking about when I told you about using parentheses. So I'm going to do g of 2. We all know how to do that because we've done that before. So all we're doing is we are replacing our x with 2. So this is negative 4 plus 8 plus 1, okay, which gives me 4 plus 1, which is 5. So that's the answer for that one. Now, let's go on to the next one. And this time, what we're going to do is we're going to replace it with t. So I'm just going to use a different color. So we'll do it in green. So this time, I'm going to say g of t is equal to negative t squared plus 4t plus 1. So g of t is equal to negative t squared plus 4t plus 1. Pretty simple, right? So the next one, this is the one that gets people, and don't let it get you. Again, if you use the parentheses, so we're going to do g of x plus 2. So wherever there's an x, we put parentheses and replace it with x plus 2. All right, so now we're going to go through and solve this. So the first thing I'm going to do is I'm going to go ahead and multiply out x plus 2. So I get negative x squared plus 4x plus 4. I'm going to distribute the 4 through, plus 4x plus 8 plus 1. Okay, now take that negative all the way through, so I get negative x squared minus 4x minus 4 plus 4x plus 8 plus 1. And finally, just reduce that down. So negative x squared, and then I've got a negative 4x and a positive 4x. I got a negative 4 and an 8, which gives me 4 plus 1, so plus 5. So here's my final answer. That's what g of x plus 2 is. All right, I'm going to give you the opportunity to do the example, so go ahead and pause and then come back when you're ready. Okay, here's the answers. All right, let's move on to the next. Okay, we're going to look at example 4. So evaluate the function when x equals negative 1. All you're doing is you're playing a game. So we need to look to see which function we're going to use. So our first one is x equals negative 1. I look at my rules, and if you look right here, x is less than 0, so I'm going to use that one. So I'm going to say f at negative 1 is going to be negative 1 squared plus 1. So, okay, so what I get is 1 plus 1, which equals 2. All right, the next one I'm going to look at is the next rule. Now I want to know, where is x equal to 0? And if you look here, x is greater than or equal to 0, so that's the function I'm going to use. So f at 0 equals 0 minus 1, so it equals negative 1. All right, the final one I'm going to do is x at 1. So again, I'm looking at this one where x is greater than or equal to 0, which means 1 is in there. So I'm going to plug it into this one. So f at 1 is equal to 1 minus 1, which equals 0. Okay, so it's your turn. Go ahead and pause and do the checkpoint. Come back when you're ready to try it. All right, here's the answers. Hope you got them right. All right, let's move on to example 5. So here it tells you, find the values for which f of x is equal to 0, which means we're going to replace f of x with 0. So we're actually solving these. So 0 equals negative 2x plus 10. And so if I solve that, that means I'm going to take my 10 over. So negative 10 equals negative 2x, and then divide by negative 2. So x equals 5. All right, my next one is not that simple. Here, I'm going to replace it with 0. X squared minus 5x plus 6. This is where you're going to have to factor. So 0 is equal to, and I need to factor this, so x and x, 6, 1 minus plus. Okay, so now what I do is I set each of these values, each of these terms equal to 0. So 0 equals x plus 1, therefore x equals negative 1. 0 equals x minus 6, therefore x equals 6. So what we're looking at here is we're looking at the roots or the solution of this equation. Okay, if you forget how to factor, I'm going to put another video on how to factor. So let's go to the checkpoint. Go ahead and stop and give it a go. All right, here's the answer. Okay, let's move on to example 6. So, example 6, find the value of x for which f of x is equal to g of x. So literally, we're just setting these two equations equal to each other. F of x equals g of x. F of x is x squared plus 1. G of x is 3x minus x squared. So now we're going to solve for it. So we're going to get everything over to one side. So if I bring x squared over, I've got 2x squared minus 3x plus 1 equals 0. And what I need to do now is I need to factor this. So I've got 2x and x, and then 1, and minus and minus. So I got negative 2x and, oops. Okay, so I've got 2x minus 1 equals 0, and x minus 1 equals 0. So 2x equals 1, therefore x equals 1/2. X equals 1. Here's my two solutions. Okay, let's go to B. And B says this one is equal to this one. So we've got x squared minus 1 equals negative x squared plus x plus 2. Again, I'm going to bring my x squared over, so I get 2x squared. Bring my x over, minus x, and bring my 2 over, minus 3 equals 0. I need to try to factor this. So 2x and x, 3 and 1, minus and positive. So 2x minus 3 equals 0. X plus 1 equals 0. Therefore, x equals negative 1. And then 2x equals 3, so x equals 3/2. All right, let me just add, I wonder if I can just add a page in here. I can. I'm just going to add a page, and I'm going to do a real quick how to factor with the x way. So this is just one way to do it. Okay, let's say I have the function 4x squared minus 5x minus 6 equals 0. So with the x, this is what you do. So if you take a look and you want to look at your two end numbers, the front and the end. So this is 4 times negative 6. So it's negative 24. All right, and then the other thing I want to do is I need to come up with a way to get negative 5. So I'm going to look at my multiples of negative 24 in order to, when I add them together, I get negative 5. So I'm going to start thinking of ones. So I've got, let's see, 2 and 12, let's say negative 12. When I add those two together, I don't get 5. There's no way for me to add 2 and negative 12 or negative 2 and 12 to get negative 5. They're not going to work. But the ones that do work are 8 and 3, and I want negative 24. So one of them has to be negative, and I want it to be negative 5. So that's going to work. So I'm going to use negative 8. So what works here is negative 8 plus 3. These are multiples of negative 24. So now what I'm going to do is I'm going to go x minus 8 and x plus 3. The only other thing that I've got going on here is I had a number in the front. If you have a number in the front, you have to divide by 4. If it will divide, you're good. So here, this is x minus 2. If it will not divide nicely, like here, you put the 4 in the front. 4x plus 3 equals 0. Done. It's factored. So now I could solve that and say x minus 2 equals 0, 4x plus 3 equals 0, x equals 2, x equals negative 3/4, and you're done. Okay, let's move on to the next one. Okay, so this time what we're going to do, oh, I just saw this, there's a checkpoint. So go ahead and pause and give the checkpoint a go. Come back when you're done. Okay, here's the answer. All right, now let's go to this next one. Finding the domain of a function. The domain of the function is literally its x values. Okay, so for A, on this one, your domain is just going to be, this is for A, -3, -1, 0, 2, and 4. Okay, for B, what we need to do here is we need to figure out what makes this function here, what makes it illegal. So if I look at that, the only thing that makes this function illegal because it's a fraction is for the denominator to be 0. So where x equals -5. So that means my domain is going to be -infinity to -5, not included, union -5 to infinity, or all real numbers except x cannot equal -5. Same thing. All right, let's go to the next one. Now we're going to here. And if you take a look at this one, oh, okay, if you think literally the volume of a sphere, the only thing we can't have is the radius can't be negative, right? Because it wouldn't make sense. And if the radius was 0, you'd have no volume. So seriously, your domain is that r has to be greater than 0. Okay, last one. This one here. What we need to think about here is what makes this function illegal. And what makes this function illegal, because we're not going to get into imaginary numbers at this time, everything underneath the square root has to be greater than 0 or equal to 0. So 4 minus 3x has to be greater than or equal to 0. So -3x greater than or equal to -4. Remember, when you divide by a negative, it changes your sign. So x is less than or equal to 4/3. Therefore, your domain is all the x's less than or equal to 4/3. So you can say -infinity to 4/3 included. All right, there's a checkpoint. Go ahead and stop and give it a go. Okay, here's the answers. By the way, take a look at the green here. This means including 16. This one means can't be included. All right, let's go to example number 8. You work in a marketing department of a soft drink company and are experimenting with a new can for iced tea that is slightly narrow and taller than a standard can. For your experimental can, the ratio of the height to the radius is 4. Write the volume of the can as a function of the radius. Okay, so for A, the volume of a can is the formula is pi r squared h. And we said that the radius, the height, the ratio is 4. The height of the radius is 4. So what we need to do is we need to take that into consideration for height. So pi r squared, and then our height is going to be 4r because that was our ratio. So our final function is 4 pi r cubed. Okay, the next one, write the volume of the can as a function of height h. So we've got volume is equal to pi r squared h, right? So if you remember, we said that the ratio of the height to the radius is 4. So that means here we've got pi r squared, and this time we've got h over 4. Excuse me. Wait. Sorry, got the wrong one. I'm doing the wrong one. Okay, pi r squared, we're doing the radius. So we're looking at pi, and then for r, we're doing h over 4 squared and h. So what we end up with is we end up with pi times h cubed over 16, or you can put it all over the same thing. Okay, so what we said is the ratio of the height to the radius is 4. So that means height is equal to 4r. That's how we ended up with here solving for the r, and here just replacing our h. All right, you have a checkpoint, and well, actually, just go on to example number 9 because this video is getting kind of long. So let's go to number 9. The batter hits a baseball at a point 3 feet above ground at a velocity of 100 feet per square second and an angle of 45 degrees. The path of the baseball is given by this function. It actually gives us a function, which kind of sucks. Where f at x is the height of the baseball in feet, and x is the horizontal distance from the home plate in feet. Will the baseball clear a 10-foot fence located 300 feet from the home plate? So again, we need to go back and think what's going on. X is the horizontal distance. F of x is how high it will go. So we want to look at f at 300 to see what its height will be. So we're just plugging in 300. And when you plug that all in your calculator, you end up with 15. So at 300 feet, it's going to, at 300 feet horizontal distance, it's going to go up 15 feet. So yes, it will clear a 10-foot fence. Okay, you can go ahead and do the next checkpoint, and I'll just put the answer real quick. So go ahead and pause. And the answer here is no, because it's going to go 13.2 feet, and he would have to jump to catch it. Okay, let's go to example 10. So example number 10, we only have 2 more examples to go. The number S of fuel stations that sold E85 gasoline in the United States increased in linear pattern, shows below, and then increased in a different linear pattern from 2012 to 2015. So what they did is they broke this up in between the 2 years. These 2 patterns can be approximated by the function, where t represents the year with t equals 8 corresponding to 8. So this is where I said you don't have to use the actual year of 2008. You can use 8. Use this function to approximate the number of stations that sold E5 between 8 and 15. So this is when we're going to use our calculators, and we're going to plug this into the calculator. So we're going to do S at 8 is where you'd go 260.8 times 8 minus 439. And let's see, when you plug that in your calculator, it's 1647. Then we're going to do 9, and we're going to replace the exact same thing, except for in here, you're going to put 9, and you get 1908. And then you're going to do 10. You're going to use the exact same function, this blue one, because we're going from 8 to 11. You're just going to go through and you're going to plug them all in. You get 2169 and then 2430 at 11. So this is 10, this is 11. All right, when you get to 12, now you're going to use this function, and you're going to do S at 12 is equal to 151.2 times 12 plus 714, and you get 2528, and then you'll plug in 13, 14, and 15, and get 2680, and then you get 2831 and 2982. So it'd be easy if you had the TI Inspires, because you can just copy your function, bring it down, and then just take out that one number and put it in. Okay, so I'm going to skip the checkpoint again. I really want to go into this next one because what I want you to see is we are evaluating a function, but we're evaluating with different values. We got x plus h and then straight up f of x. Okay, so what I'm going to do first is I'm going to do the f of x plus h. So f of x plus h is equal to x plus h squared minus 4x plus h plus 7. So if I do x plus h squared minus, take the 4 through, so x times x gives me x squared. Xh and xh is 2xh plus h squared minus 4x minus 4h plus 7. That gives me the f of x plus h. So I'm going to now put it all together, and we'll put the f of x plus h on the top. X squared plus 2xh plus h squared minus 4x minus 4h plus 7. And then I want to subtract, and I want f of x, which is just x squared minus 4x plus 7. All of this is over h. So if I'm going to take that negative all the way through here, so my ending function now is x squared plus 2xh plus h squared minus 4x minus 4h plus 7. Take the negatives through, minus x squared plus 4x minus 7 all over h. What we're going to do now is see what we can take care of. We can get rid of the x squared and the negative x squared. We can get rid of the negative 4x and the positive 4x, and we can get rid of the positive 7 and the next negative 7. I'm left with, let me make myself a little bit more room, and I'm going to go up here. I'm left with 2xh plus h squared minus 4h all over h. If I factor out an h out of the top, I get h and then 2x plus h minus 4 all over h and cancel. My final function is going to be 2x plus h minus 4. All right, you guys want to give it a go? Go ahead and give it a go, and I'm just going to put what the final answer is. Just see if you can get it. Go ahead and pause. I hope you got it. We're all done.